Well, now when it comes to solving logarithmic equations, this is really about as bad as it gets right here. This is an example right here of a logarithmic equation where we've got several different logs jammed together by addition and subtraction on one side or both sides of the equation, and we have to find a way to solve the value of x. Well, in fact, the nice thing about logarithms is that our properties of logarithms are really easy to solve if we remember some of our other properties. This, for example, even though you may not recognize it right away, is actually one of those properties. Specifically, we had a property that said if we had a logarithm, base a of the quantity u times v, that was exactly the same as taking the logarithm base a of u added to the logarithm base a of v. And so we can use that property over here on this left-hand side to rewrite this as a single logarithm. So we would actually have on the left-hand side the natural logarithm of the quantity x times x minus 1. And that's equal to the natural logarithm of 4x, like we have over here on the right-hand side. Now, this is a very handy thing to know because now we can go to our one-to-one logarithm property. And if you recall that property, that's the one that said, well, if we have a logarithm, not lag, log, uh, logarithm of x equals the logarithm of y, then it implies that x equals y is the only solution right here, right? So we're going to use that property to help us isolate x in the equation above, right? So if the natural log of the quantity x times x minus 1 is equal to the natural log of the 4x, then it must be that x times x minus 1 is equal to 4x. And it's suddenly a lot easier to solve because now we get the following. X squared minus x equals 4x. We subtract 4x from both sides because this is the kind of equation where you have to set it to 0. Don't forget it's quadratic, right? So we would have x squared minus 5x is equal to 0. Now we have to factor. We get x times the quantity x minus 5 is equal to 0. And this is going to give us two possible solutions. It's going to give us x equals 0 as one possible solution, and it's going to give us x equals 5 as our other possible solution. This is where you need to check, because when you solve logarithmic equations, you may get several solutions, but not every solution will work. Will every solution work here? The answer is no, because if you put in x equals 0, the natural log of 0 minus 1 is undefined. And so we cannot use x equals 0 as one of our solutions right here. So this is not a solution. This is extraneous. This is our extraneous solution. Now, on the other hand, if we try it with x equals 5, it should work because we're going to be taking the natural log of 5 minus 1, adding to it the natural log of 5, and that should be equal to the natural log of 4 times 5. Well, yeah, it is. That's true, right? That's what our multiplication property says. And so we have a good solution right here in x equals 5.